Okay, so today is the 6th. Today we're going to be doing rates. Is it recording? I can't tell. Oh yeah. Rates of change and calculus. So before we get into the actual calculus part, just like we did in the do now, we're going to review some old vocabulary. And then we will start new vocabulary and do examples. Okay. Our first review vocabulary is slope. Does anybody remember the definition of slope? Not the formula, the definition. Value. Close, but not really. That's okay. Thanks for trying, Tiffany. It is a value. It's the value. So it's value. Did I spell it right? Why does that look weird? That describes, am I off screen? No. The steepness of a line. It is the value that describes the steepness of a line. So it can be positive, it could be negative, it could be a whole number, it could be a decimal, it could be a square root. Okay, it's going to be some number that we calculate. The formula for slope, can you see that color? Okay, that was enough. What about this one? The formula for slope is, bless you, y2 minus y1 over x2 minus x1 when you're given the formula, or the points, x1, y1, x2, y2. Okay. So this is the formula, and this is the given information, which you did on the do now. You found the slope of a line by comparing the difference of the two coordinates. This should just all be a review. The next review vocabulary word is y-intercept. Anybody remember the definition for y-intercept? Yeah, use words. It is the value where the graph intercepts what? It is a point though. The y-axis. Okay. You don't see that color. That value is 0, comma y. It's going to be some, I can't use these. I can't see them. Vanessa? So if the y-intercept crosses the, or intercepts the y-axis, what would the x-intercept cross? If the y intercepts the y, the x intercepts the x. Very good. The value. Am I missing something? Are we too close?
I think we too far. I think we too far.
As a social exam, I mean,
So we want to sit together so we can get in trouble every day? Yeah? Because I will sit next to each other and remove you every day if you'd like. Yeah? All right, let me ask your mom if she wants it. The value where? The graph. You guys are too goofy, man. Well, that too. Intercepts the x-axis. That's going to have a value of x comma 0. Sorry for those of you who are on task. For the x-intercept, we can have multiple x-intercepts are possible. But we can only ever have one y-intercept, ever. That is the definition of a function. We cannot cross the y-axis more than once, otherwise it is not a function. Miss Santana, what do you mean? Great, here's an example. Let me draw you an example. Use this one. Can we see this color? No? I need new markers. Okay, so let's take this function right here. This is called a cubic function. This function has a y-intercept here. Why is this a y-intercept? Because what? It intercepts what? The y-axis. It intercepts the y-axis. But here I have 1, 2, 3 x-intercepts, and that is okay. You can only ever have one y, but you can have multiple x. All right, Miss Santana, this is easy. I learned this in 8th grade, or I remember Miss Eckbert taught this to us. Yeah, cool. That's great. We need this basis in order for the calculus part. Okay, we need this basis for the calculus part. Does everybody have this so I can move on? Done? Almost? Huh? You sure? I still see people. Let me know. Nuria, ready? Okay. Kimberly? All right. Okay. So let's say we have that curve again. Let's say we have, and just to be sure, it doesn't have to look exactly like mine. Just make sure it looks kind of like squiggly or whatever. It doesn't have to look exactly like mine. Slope is used for linear functions. What type of graph is a linear function? A straight line. This is not a straight line, but we can calculate the slope or the rate of change. Because remember, rate of change means the same as slope, means the same as unit rate, means the same as rate. All those things mean the same thing. We're looking for the difference, the change, or the average rate of change between two things. So in calculus, when we're doing the slope in quotes, we are actually looking for the average rate of change. We're looking for the average rate of change. The average rate of change, Vanessa, here's the notes if you need them, is the rate of change over an interval of a curve. This is the key, interval. Does anybody know what interval means? It's okay if you don't. So we'll write that definition here. Interval is a range of values. Interval is a range of values. So in this case, our interval is going to be denoted by brackets. These are like the square brackets, I guess. And you're going to have two values, an x1 and an x2. So we're going to be looking over an interval of two x's. We're going to be looking over an interval of two x's. Questions so far? I know it's a lot to think about. Any clarification on any definition, any symbols? Okay. So because we can't use slope, I mean we will be using slope. Like we'll be using the slope formula, but we won't be calling it slope. We're calling it average rate of change. And we're going to be using the symbols, the change of y over the change of x. This delta, this is delta. Delta. Can you see this? Am I off screen? Delta means the change of. Okay? So we're going to be looking for the change between the y's and the change between the x's. Change between the y's and the change between the x's. So that's going to be f of x2, and I'll explain what this means in a minute. F of x1 over x2 minus x1. These f's are just the function. So this is just the function. Evaluated at those points. Okay? So it's basically your y2 and y1. y2, y1. When you are done writing that down, take out your example sheet. Does everybody have an example sheet? I know we're not sleeping, right? Maybe he should sit there. Are we good? You guys cannot face each other. Okay, let's look at our first example. Our first example asks us to find the rate of change between the given interval for the graph or the function. Okay, so level 1 is going to be graphs and functions. Okay, that's what level 1 is going to be. It's going to be a graph and a function. What did I say are the values in the interval? Jose, sit up. What are the values? X1 and and x2. Okay, so we have half of our coordinate. We have -1 and 0. Are there any questions on where I'm getting those numbers? Any questions on anything so far? Are we sure? Okay. But how can we find, bless you, the y value that goes with these x values on the graph? Not necessarily. It's not always going to be the y-intercept. Not always going to be the y-intercept. Which one of these will be the y-intercept, though? The 0 one. Okay? So then what is that? What is that coordinate? 1. Okay? Y-intercept aside, how did we find that that's going to be 1? How do we find it? Yeah, that's where it touches the y-axis, right? We can find another coordinate on there without it touching the y-axis, but it's touching a point. So if I go to -1 here, right, that's what we got, -1. I'm going to go here. What is this value of y there? 1, also 1. Questions? We sure? Okay, so now we have our coordinates. Now we can find the average rate of change. So we have delta y over delta x. So this is my x and this is my f of x. Okay? This is my f of x1 and x1, and this is my x2 and f of x2. And I know that it is f of x. Even though this says y, it's still a function. It's still a function. Remember, y and f of x are interchangeable. So how can I put it into my formula to find the average rate of change? Look in your notes. 1 minus 1 over 0 minus -1. Very good. All right, everybody put this in your calculator. How do we put a fraction in calculator? Ignore the numbers in the front. These? Yeah, this is just the function that models this graph. So as long as you have a graph, you can just use that. What do we get? I heard somebody say it. 0. We get 0. So that is the average rate of change between these 2 points. That is the steepness of this line. It is not going up. It's not going down. It is a straight line. That is why the average rate of change between those is 0. It doesn't change. And you can see that if I drew a line. If I did this, right? There's no change. Questions? Are we sure? Okay, then what I want you to do is letter B with your groups. Do letter B with your groups. 1, 2, 3. Why is this not working? Bless you. 1, 2, 3. 3 minutes. Letter B with your group. Yeah. Which part do you need?
I already did the.
You did these? So you need this one? No, you didn't. I think you were gone for that part.
Yeah, it was.
Okay. Oh, we don't like your new group, so we're not going to talk? Oh, so sad. Not really. Oh.
Okay, wait. I'll show you this in I said I was going to share.
What's up? Just go to that number, the x value, and then go up or down to where it crosses. Should I cold call on somebody to make sure they're doing it.
Did I do this right?
-1, 2. This one's not right. Because if you go to 1, it's not 2. 2's up here. Where is it at?
1. You're right. 1 is negative 2.
Yeah, not positive 2. I know it is. I know. That's why it's a level 1.
I hate to run around. I don't like it.
What? I'm sorry. Thank you.
Yeah.
Okay.
No.
No. Too late. All right, seniors, check your work, check your work, check your work. This is correct. Thank you, sir. I'm gonna freeze it. I can't freeze it. This thing's not working. Freeze. There you go. Thank you so much. You should get -2. Sit lightly. Questions? If you did not get -2 because you were sleeping, or you did not do it right, or you just waited until I put the answer up, put it down on your paper. Yes, I'm throwing all the shade. What about it?
Are we following that formula?
Yeah. Are we good? Are we sure? All right, cool. Let's move on. I'm taking this down. Does everybody have it down? Oh, too bad. Okay. Do I have a graph here? No, but can I find out, Elvis? Can I find out my values? Yeah, how do I do that? How do I do that?
That's a good question.
Yeah, I know. Okay, first of all, what are these? X1 and X2. How do I find Y1, Y2? You know it. Starts with an S.
Slope.
No, not slope. Go ahead, just keep throwing out S math words. Symmetry. No, this is not geometry. If I have my X's and I'm trying to find my Y and I have a function, substitute. Thank you, Alexandra. We substitute. So in order to find Y1, I'm going to substitute in what? If I'm trying to find Y1, what should I be substituting in? X1. Questions? We're sure? Okay. When we put this into our calculator, we get 2. So this is my Y1. So my my coordinate is -1, 2. So that's my first one. How do I find my second Y2? And what's X2? 0, very good. So Y2 is going to be, or not to be, 0 squared plus 1, which is 1. So my next coordinate is 0, 1. Now do I have 2 coordinates to find the average rate of change? I do. So it's the change of Y over the change of X. So 1 minus 2 over, bless you, 0 minus -1 And you get -1. Should get -1 if I did my math right. Questions? What's wrong? You look confused. Okay, so we only have my x values, Rafa. Okay, got that? In order to find the y, I need to substitute in the x's to get y. Okay, so I'm gonna substitute in -1 first. I did that here, so we have -1 squared plus 1. When you put in your calculator, you get 2. So that's your y1 that goes with your x1. Okay? Sure?
Yeah.
And then we do the same thing, so this x1, y1. Then we do the same thing for your x2. We substitute it in to get your y2. Okay? And now that we have the 2 coordinates, we use the rate of change formula to find the rate of change on that interval. Got it now?
Yeah.
Okay. All right, take the next 3 minutes to do letter D. And it is okay to have fractions. It's okay to have fractions. Stop being weird and don't like fractions. It's okay to have fractions. 3 minutes. I'm going to walk around, make sure you're doing it. If you are not doing it, it is the log. D. Yes, that's what you're substituting in. You didn't even write down C. Good. No. Substitute it in that formula. Okay, make sure you're using the right formula. Make sure you're using the right formula. Good job. 1. You want to come up there? Alright, when it's done.
What happened?
Okay? What's wrong? You doing it right? A fraction. Oh, I'm gonna make everything into fractions. It's gonna make everything into fractions. Yeah. No. These should be negative. You got your negatives. Oh, I didn't even see them. Yeah. Yeah. Now you're gonna have to redo it. William. I just don't know how to do it.
Negative.
This is right. Where's your negative? No negative.
Okay, so it's 2 and 1.
Okay. Yeah. What's your language? Oh, there should be negative 1.
0, 0, and 1.
Negative 2.
That's easy.
What? No. First of all, there should have a negative here. You don't have a negative. Okay. Close attention, close attention. Attention to details. Okay, now use your formula. Use your formula. No, fractions. Keep it as a fraction. Keep it as a fraction. You're missing your negative. Hold on. Yes. Okay, we'll read it. well, first you gotta enter the 0 first. 0 first, and then 1. Okay? Go in order. Okay? 0. Yep. And then put that in your calculator. No. Professional negative. Seniors, I see a lot of people forgetting their negative signs. Pay attention to the problem. There's a negative here. There you go, look at that. Why? What do you mean? So you did one number. What happened to this one? Yeah. No. Because you're doing x minus y, x minus y. It's y minus y and x minus x. Okay, now put in the formula video. It's not updated, grab a ruler. No. It's different. No? Do you understand that this is negative 1, right? So I need, yes. 1 is here. Yes. Okay? Find the point. Yeah, hold on. Let me get this paper because I put this underneath it. I'll be going down. Did you just add more time onto that? I know time was up. All right, let's look at Rafa's paper. Let's see if we can get this darker. Okay, can we see that kind of? Okay, this is correct. He substituted in 0 and got -1/2. Then substituted in 1 and got -1/3. Then did subtraction, and it is okay that he erased and redid it, because that is how we learn. If you did not do this because you were waiting for the answer or sleeping or you got it wrong, please make sure you're correcting it. Snaps to Rafa. Snaps to Miguel. Thank you so much. Okay. On the back, you have 6 problems. Start them. Start them.